Conditional, mutually exclusive and independent events. Example 12. This Venn diagram shows the number of students in a class who study Spanish and the number of students who study mathematics. Determine whether S and M are independent events by A. Calculating and considering the value of the probability of S and the probability of S given M, and B. Calculate and considering the values of probability of S times the probability of M and the probability of the intersection of S and M. The number in the universal set is equal to 6 plus 2 plus 3 plus 9, which equals 20. The number who take Spanish is equal to 6 plus 2, which is equal to 8. The number who take mathematics is equal to 2 plus 3, which is equal to 5. A. The probability of S is equal to 8 over 20, which is equal to 2 over 5. The probability of S given that M has occurred is equal to 2 over 2 plus 3, which is 2 over 5. Because the probability of S is equal to the probability of S given M, which is equal to 2 over 5, they are independent. Events. B. The probability of S intersection M is equal to 2 over 20. The probability of S times the probability of M is equal to 2 over 5 times 5 over 20, which is equal to 2 over 20. Therefore, because the probability of S intersection M is equal to the probability of S times the probability of M, the two events are independent events. For a consumer survey, 2,371 adults are asked questions, and an adult is chosen at random from those taking part. C is the event the adult likes coffee. D is the event the adult is called David. A. You are given that C and D are independent events. Explain why this is the case. A. Because an adult can like coffee and be called David. Liking coffee and being called David do not affect each other. B. Part 1. Because they are independent events, the probability of C intersection D is equal to the probability of C times the probability of D, which equals 0.8 times 0.007, which equals 0.0056. Because C and D are independent events, the probability of C union D is equal to the probability of C plus the probability of D minus the probability of C intersection D, which is equal to 0.8 plus 0.007 minus 0.0056, which equals 0.8014. If C and D are mutually exclusive, the probability of C intersection D must equal 0. But the probability of C intersection D is equal to 0.0056. Therefore, not mutually exclusive. The Venn diagram shows the number of students in a class who can speak Spanish, Italian, both of these languages, and neither language. The number of students, or the number in the universal set, is equal to 5 plus 2 plus 6 plus 15, which equals 28. The number of students who can speak Spanish is equal to 5 plus 2, which equals 7. The number of students who speak Italian is equal to 2 plus 6, which equals 8. A. The probability that a student can speak Spanish is equal to 7 out of 28, which is equal to 1/4. The probability that a student can speak Italian is equal to 8 out of 28, which is equal to 2/7. The probability that a student can speak Spanish, knowing he can speak Italian, is equal to 2 out of 8, which is equal to 1/4. The probability that a student can speak Italian, knowing that he can speak Spanish, is equal to 2/7. E. The probability of I intersection S is equal to 2 out of 28, which is equal to 1 out of 14. F. The probability of S times the probability of I is equal to 1/4 times 2/7, which is equal to 2 out of 28, which is equal to 1 out of 14. If Spanish and Italian are independent events, the probability of Spanish times the probability of Italian is equal to the probability of Spanish intersection Italian. Therefore, 1/14 is equal to 1/14. Therefore, independent events.